All right, hello everybody, and welcome to Algebra 1. A little unusual the way that we're having to do class, I know, but anyhow, I'm hoping to spend a little time every day with you via this video format and kind of for the first few days just do some review, and then eventually we'll move into brand new territory. But hope you all are doing well, and I understand that transitioning to the e-learning format's been kind of challenging. We're looking at the website we're using, if it's going to be strong enough to be able to host all of the classes we need to teach. So we'll see. We'll let you know if things need to change, okay? So today's assignment is review. We're going to review a couple of things. First of all, we're going to review perfect squares and square roots. So I know that you all have been working on that since early elementary school, but we're going to talk about what a perfect square is, and then what a square root is, and then we're just going to do a little review, adding, subtracting, multiplying, and dividing fractions. So first of all, let's talk about a perfect square. When I talk about a perfect square, it's a number times itself. When we write it, for example, like this, 5 squared means 5 times 5. So of course, 5 squared is 25. Now, the concept that goes along with that, with the concept of the perfect square, is the square root. So the square root is the relationship between this number, 25, and the original number, 5. In other words, the square root of 25 equals 5. And I know you've done this before a lot of times. However, you've also been on spring break, and I've noticed that sometimes your brains get full and you leak things. So anyhow, this is what we're going to do. We'll take just a couple of examples here, and you're going to need to just practice and review the perfect squares from 1, which would be 1 times 1, all the way up to 25 times 25, which is 25 squared. And then we'll work with some square roots as well. What if you're given a fraction inside a square root? Okay, so let's say that we're given a fraction, something like, myself some room here. Let's say 9 25ths, the square root of 9 25ths. Now, we can't simplify 9 25ths, but we can take the square of both the numerator and the denominator. So the square root of 9 25ths, what we're going to do is we're going to look at the square root of the top number and the square root of the bottom number. And if we can take the squares of those, then we can go ahead and get rid of this square root sign. Now, one thing I'll remind you, the square root sign looks something like a division sign. A couple differences. This line coming down here is pretty straight, and then it's got the little tail here on it. Goes. That means square root. It's not a divided by sign. Okay. If we were talking about division, then you would have, of course, a number here and a number out here, and the sign would look a little different. I'm going to talk to you about that in just a second. Okay. So the square root of 9 is 3, and the square root of 25 is 5. So if I can take the square root of 9 and the square root of 25, in other words, if I can get the square root of both the numerator and the denominator, I can take them outside of this square root sign. That means equals 3/5. So the square root of 9 25ths is 3/5. Now, what if I'm given a number and it's not a perfect square, but it's inside the square root? I can still simplify it. Let's look at what that looks like. Obviously, before tomorrow's video, I need to get a bigger eraser. But let's say I'm given the square root of 50. 50 is not a perfect square. 49 is, okay? So we know that the square root of 49 is 7, but we've got just a little bit more than 7. However, that's not what we're asked to find. We're not estimating here. We're talking about the square root of 50. Well, I don't know the square root of 50 without putting in the calculator and having a whole bunch of decimal places. But I do know that 50 has has a way of being simplified. In other words, I can break this down. I can break my number 50 down, and I can look and see, is there any number that if I start to factor 50, is there any number that is a perfect square? Obviously, in order for you to do this, you're going to have to be kind of familiar with your perfect squares. So let's look at 50. When I think of 50, I think of, obviously there's 5 times 10. Neither 5 nor 10 are perfect squares, but there is 2 times 25, right? 50 is 2 times 25, and 25 is a perfect square. So I can rewrite this or think of it differently. Instead of the square root of 50, that equals the square root of 2 times 25. Now, 2 is not a perfect square, but 25 is. So here's what's going to happen. I'm going to take the square root of 25, which is 5, and I'm going to move it outside of my square root sign. There's actually an official name for that, but since you're never going to know it, we won't worry about it. We'll just call it the square root sign. I'm going to take the square root of 25, I'm going to move it out. In other words, I got to leave my 2 inside, but I can take my square root of 25 and I can put it outside. And what that's going to look like is 5 times the square root of 2. Okay, you see what I did? I had the square root of 25. Well, I know the square root of 25 is 5, so I took it out of my square root sign, and what was left inside was my 2. Let's do another one. Let's say square root of, I'm thinking of very easy ones, and then I'm going to give you harder ones on your homework. Let's say the square root of 32. Square root of 32. 32 is not a perfect square. You know what it is, though? 16, right? And 16 times 2 is 32. So I can rewrite this one, same way as I did the one before, 2 times 16. And because 16 is a perfect square, I'm going to take the square root of 16 out. Square root of 16 is 4. That's going to give me 4 on the square root of 2. Okay, so the square root of 32 equals 4 times, or 4 on, the square root of 2. 4 times the square root of 2 equals the square root of 32. All right, so that's a little reminder on square roots and how to simplify them. All right, let me make some room here. Now we're going to talk about working with fractions. Long and tedious video. All right, so let's deal with it in this order. We're going to go add, subtract, multiply, divide. All right, when I'm adding fractions and I'm subtracting fractions, I must have the exact same denominator, okay? In other words, I can add 3/4 plus 1/4 equals, and then I add the numerators, add across. Since my denominators are the same, my answer is going to have the same denominator, right? I'm going to add the top and leave the bottom the same. That would be 4/4. And of course, if you know, any number over top itself is the same thing as 1. So that would equal 1. All right? So when I'm adding fractions, the denominator must be the same. If they're not the same, then I have to find that least common multiple. Example, if I had been given 3/4 plus 1/8, I can't add those two. They don't have the same denominator. They've got to have the same denominator. So what do? I'm going to look at the least common denominator, the least common multiple that this and this will both go into. Well, obviously, these are very simple examples, right? The least common denominator between 4 and 8 would be 8, right? 8 times 1 is 8. 4 times 2 is 8. So I'm going to rewrite my fractions. Now, because this one is already in eighths, I'm going to leave it. I'm just going to drop it down here. This stays 1/8. However, I need to convert 3/4 to eighths. They have to have the same denominator. Now, what did I do to get this denominator, 4, to equal this denominator, 8? I multiplied it times 2. Well, if I do it to the bottom, I have to do the same thing to the top. And if I do, then the value doesn't change. So if I multiply the bottom times 2, I'm going to multiply the top times 2. So 3/4 is the same thing as 6/8. Add across. My answer is 7/8. All right? So, more erasing. Let's subtract. Subtract requires the same thing. You have to have the same denominator. All right, so let's say that we've got 2/3 minus 1/3. Denominator's the same. I just subtract across. 2 minus 1 equals 1. Denominators stay the same, 1/3. Cool. All right. What if I had, though, let's do a little more difficult one. What if I had, I don't know, 7/8, and I'm subtracting 5/6. Ooh, all right. 7/8 subtracting 5/6. I need to find the lowest common denominator that would include both 8 and 6. Well, let's think about it. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Well, 6 times 4 is 24. So these both have a common multiple, and it is 24. That's the least common multiple, so it's going to be our lowest common denominator. And I'm going to rewrite both of these fractions as 24ths, okay? So I'm going to write this one as a 24th. I'm going to write this one as a 24th. All right, so let's think about this. If I multiply the denominator times 3 to get 24, I have to multiply the numerator times 3 as well. Okay, so 8 times 3 is 24. 7 times 3 is 21. If I multiply the denominator times 4, I have to multiply the numerator times 4. 6 times 4 is 24. 5 times 4 is 20. 21 minus 20 is 1/24. So what's the difference between 7/8 and 5/6? 1/24. All right. Now, just like subtracting with whole numbers, I can end up with a negative answer if I'm subtracting if I'm subtracting a larger number from a smaller number. For example, if I were to say 5/7 minus 6/7 equals, since I don't have to convert since the denominators are both already sevenths, but 5 minus 6 is a -1, okay? So what I can do here is I can say -1/7. So -1/7 is the same as -1/7 is the same as 1/-7. All those things are the same, all right? Doesn't matter where I put the negative sign. Usually, I'm going to put it right here in the middle, like that. That's just more universal and fewer chances of losing track of it, okay? So we're good to go there. Now, when it comes to multiplying and dividing, I don't need a common denominator. I really didn't think about how long and awkward this is going to be to erase every time. All right, so let's multiply some fractions. Let's do the one we just did. Okay, let's do 6/7 times 5/7. Those are a couple fractions we just saw. However, they're not in the same order, but let's multiply. Okay, now if I'm multiplying my fractions, I don't have to have the common denominator. They don't have to be the same. I'm just going to multiply across, but I have to multiply the top and the bottom. In multiplication and division, the denominator will change in our answer. It didn't in addition and subtraction, but it will change in our answer. So 6 times 5 is 30. 7 times 7 is 49. Those numbers cannot be reduced. That's my final number. All right? So if I'm multiplying and I have fractions that can be simplified, here's how that would work. Let's say I have 3/15 times 5/9. Okay? Now I can multiply the numerators, 3 times 5. I can multiply the denominators, 9 times 15. Going to give me the right answer. However, if I go ahead and cross-simplify, you remember cross-simplifying, if I cross-simplify, it's going to give me an easier problem to work with. Smaller numbers, going to be better, especially once these start getting really big. So I'm going to look at the diagonals, and if those numbers can be divided by the same number, then I can simplify them that way. So 3 and 9 are both divisible by 3. So I'm going to divide 3. I'm going to call the new number 1. And here I'm going to divide 9 by 3, and I'm going to call it 3. Okay? These two diagonals can be simplified as well. 5 simplifies to 1. 15 simplifies to 3. Now I'm going to multiply numerator times numerator, denominator times denominator. Okay? 1 times 1 is 1. 3 times 3 is 9. All right. That is multiplying with simplification. All right. Now division. All right, in division, I also do not need a common denominator. However, I've got to make a change to my fraction before I can complete my problem. So let's say that I am given 3/7 divided by, I don't know, 2/5. Okay, 3/7 divided by 2/5. That's kind of a pain, right? Now what I'm going to do is I'm going to keep the first fraction. I'm going to change my sign from division to multiplication, and I'm going to flip my second fraction. Okay? Keep, change, flip. Keep it, change the sign, flip it. All right, so here's my keep. 3/7 stays 3/7. Divided by becomes multiplied, and my flip, 2/5 becomes 5/2. Now I multiply, numerator times numerator, denominator times denominator. 3 times 5 is 15. 7 times 2 is 14. All right, and there I go. Now that's an improper fraction, and I can either leave it that way if the answer is requested just as a fraction, or I can convert it. 15 over 14 is the same as 1 and 1/14. In other words, when I divide 15 divided by 14, my answer is 1 with 1/14 left over. All right, so that's our assignment for today. We'll be moving forward with several things here soon. We're going to review some concepts that we studied before spring break. Just want to get everybody back on the same page. So anyhow, hope you're doing well. Love you guys. Praying for you. And don't drive your grown-ups crazy. Let's have a good time. And we'll see you whenever we see you.